Okay, so when you're asked to find the inverse of a 2 by 2 matrix, they give you this 2 by 2 matrix and they ask you to find the inverse. So this is what the a raised to, it looks like a raised to the negative 1 power, but that's not. It means the inverse of a. Okay? So that's the inverse of a. And then this down here looks like the absolute value of a, but that's not. That's the determinant of that matrix. Okay, so you have to be a little bit careful when you're reading this and looking at the example. It looks like they're the symbols that you've seen before used in a different way. And that can be a little bit confusing, I know. So you want to make sure that that's clearly stated in your notes so that when you see these, you know what they mean when they're referring to a matrix. Okay, so now this is the formula that you're going to need, and I would make sure you have that in your notebook. Maybe put it in the back of your notebook where the formulas you're going to actually need to have quick and easy access to. I don't expect you to memorize all of that stuff, so that helps. But you've got to understand what it means. So, first of all, I didn't mean to make that little mark. Okay. So let's talk about what each of these things mean. So the determinant, remember, to find that we'll multiply these two numbers together and subtract these two numbers, and that gives you the determinant. Okay? And then this does not mean 22, a sub 22. It's actually referring to, the first number refers to the row, and the second number refers to the column. So A22 means row 2, column 2. So these are rows, row 1, row 2. These are columns, column 1, column 2. So row 2, column 2 is this number right here, is this position here, which is -4 in this case. Okay, and so this one, the opposite of the value in row 1, column 2. Row 1, column 2. That is 3. And we're going to take the opposite of it. That's going to be a -3. Okay, and then this one right here, the opposite of that's supposed to be a 2, row 2, column 1. So row 2, column 1 is a -1, but you take the opposite of it, so it would make it a +1. Okay, and so now you get the idea here. This is row 1, column 1. Row 1, column 1 value, the value of row 1, column 1. Okay, so what basically we're going to do is figure these things out, plug them in there, and go from there. So the inverse of this matrix given here is going to be 1 over the determinant, so that's going to be 4 times the -4, so that's a -16, minus, -1 times 3. So that's a -3. Okay, so we'll come back and simplify that, and then let's go ahead and fill in our matrix here. And so it says to take the value at row 2, column 2. Row 2, column 2 value is a -4. We put it there. Okay, and then in this position we're going to take the opposite of row 1, column 2. Row 1, column 2. So that's a 3. We're going to take the opposite of that, so that's a -3. And then here we're going to take the opposite of row 2, column 1. Row 2, column 1 is a -1. We're going to take the opposite of that's a +1. And then the very last position over here, we're going to put the value of row 1, column 1. Row 1, column 1 is right here, 4. So then it's just a matter of simplifying this, and then we do our matrix multiplication, which is just multiplying each part in here by this value here. So we can take this and turn this into a plus, a positive, and that looks like it's going to end up being a -1 over 13. right? Because this becomes 1 over a negative 13, and I'm just going to pull that negative out in front. Okay, and we're going to multiply that by our matrix here, which is a negative 4, negative 3 in our first row, and our second row is 1, 4. Okay, and now it's just a matter of multiplying each of these values by a negative 113. So a negative 113 times a negative 4 is a positive 4/13. A negative 1/13 times a negative 3 is a positive 3/13. And negative 1/13 times 1 is a negative 1/13. And a negative 1/13 times 4 is a negative 4/13. Put that in the little matrix notation here. And that is your answer.